I'm Skylar and welcome to Tech Edge. Before we get started, hit that subscribe button so you don't miss out on our upcoming videos and live events. So if you've spent time researching or talking about automation, quality control, automated or any range of other machine vision applications, you might be asking, what is Lidar? Today we're going to discuss how it works, what it measures, and what it's used for. Let's dive in. Lidar is an acronym for Light Detection and Ranging. It is a powerful technology for measuring relative distance, and it's an increasingly common element in a wide range of IoT and Industry 4.0 projects. So, how does Lidar work? A Lidar system bounces eye-safe laser pulses off of objects to locate and measure them. A laser beam transmitter emits the light, which is returned to a receiver. At that point, calculations are made by a Lidar Processing Unit, or LPU. Lidar systems share many common elements with traditional radar, but the wavelength of light used is thousands of times shorter than the shortest radar wavelengths. This allows super accurate results to be delivered very quickly. Lidar relies on the TOF, or time of flight principle. Laser light is emitted at time t-0, hits an object, and the reflected light is then measured at time t-1. Because the speed of light is a known quantity, the measured interval can be converted into a precise distance. In addition, by calculating how much light returns to the sensors, the size and shape of objects can also be determined. Alright, that's pretty cool, but what does Lidar measure? LPUs use the information they gather from Lidar sensors to calculate distance, size, and shape to create 3D maps or inform actions in a process. Let's take one of our customers, FlashEye, for example. Their solution monitors conveyor belts in the mining industry. Using optimal performance models as a reference, their devices can identify deviations in conveyor performance and alert operators. These alerts can be used to generate maintenance plans, protecting workers from potentially dangerous conditions, and optimizing operational output. Lidar is becoming a popular solution for automated measurement applications that don't need or don't want to capture full resolution image or video data. Because it only measures relative distance, users concerned about personal privacy and anonymity can collect actionable data without also capturing identifying information. As a result, security and surveillance applications using Lidar are becoming increasingly popular. This is particularly true in Europe, where GDPR privacy laws impact some types of traditional security monitoring. Next, let's talk about what Lidar is used for. The automotive industry has driven, no pun intended, much of the interest in Lidar in the last decade or so. Many modern safety features found in cars and trucks rely on Lidar. In addition, autonomous vehicles utilize the technology to identify and avoid obstructions, other vehicles, and people. There are a host of other applications that are finding ways to benefit from super fast, hyper-accurate measurement data. According to ABI research, the number of Lidar sensors used outside of the automotive industry is expected to reach 16 million by 2030. For example, in architecture or construction, it's used for building information modeling, or BIM. In smart agriculture, Lidar is used for precision farming and autonomous equipment. In smart cities, it's used for mobile devices for managing city infrastructure and assets. It's also used for tree encroachment detection for power transmission lines in the energy industry, quality assurance defect detection for manufacturing, and in mining, Lidar can be used for hazard detection, mineral exploration, and extraction monitoring. So, long story short, Lidar's appeal across industry has led to continued development and expansion upon its capabilities. In addition to measuring 3D position, emerging 4D Lidar technology will also provide simultaneous velocity data, opening up new application possibilities. Those installations and those already being deployed will increasingly require LPUs to be installed outside of climate control areas. Now, Our industrial and rugged computers are built to stand up to challenging conditions, so if you're working on implementing a LiDAR solution, connect with our team today to see how we can help. And before you go, give this video a thumbs up if you found it helpful, and leave comments or video suggestions below. As always, thanks for watching, and see you next time on Tech Edge.